Okay, so we're still in 2.5. I forgot what we were in, 2.5. We're doing number 9 now, and it says Carlos has already written the rule for g of x equals 1/2 to the x for this function. Ta-da. What is the other rule he's thinking about? Sorry, I forgot your context. All of this work with negative exponents make Carlos realize something. I can write 2 different exponential rules for the same function. Now, we've written a bunch of them over and over again, and I keep referencing these things. These 2 things should look different, but they will be the same, right? Right? So, and this refers back to why this lesson is actually called twin powers, right? Twin powers, because we're talking about rules of power, so power of power, but then we're also talking about twins. So they have the same value, but they look different, right? So looking here, what do you see is he talking about? What is Carlos talking about? All of this work with negative exponents has me realizing something. I could write 2 different exponential rules for the same function. Where do you see 2 different exponential expressions that have the same value? Where do you see them? Remember, this is me saying a $20 bill and 2 $10 bills. Where do you see that here? I'll give you a hint. One of them has a negative exponent. So we're looking for expressions that are the same. We're looking for expressions that are the same, but they look different. Where do you see expressions that are the same, but they look different? No, because reciprocals don't have the same value. Reciprocals don't have the same value. Look for things that I've said over and over again. These 2 things are the same, but they look different. Be specific. I need specific what you see here. So I'm looking at this and I see a lot of things that are the same value, but they look different. Yes, 5 squared equals 5 times 5, but I'm more looking for stuff with exponents. It's got to be exponents. Yeah. So someone says this, Miss Johnson, these 2 things are the same to me. Right? These 2 have the same value. So here, these, like these, this is what Carlos is talking about right here. 1 to the 5th, 1/5 to the 5th, and 5 to the negative 5th. Right? These 2, 3 to the negative 6 is equal to what? 3 to the negative 6 is equal to what? Yeah, 1 over 3 to the 6th, right? What about this one? 1 over 5 to the 5th equals to 5 to the negative 5th. Are there any more? I think that's it. So now we're going to go over here. 1/2 to the x. What's another way to write this function? So thinking about what one of your classmates wrote, what's another way to write 1/2 to the x? Do you guys agree? Someone says this, Miss Johnson, I think it's equal to 2 to the negative x. Let's test it, right? What does this negative exponent mean? What does this negative exponent mean? What does the negative exponents mean? Yeah, to divide. Oh, that's why you put them down here, Miss Johnson. Yeah. Okay, so another way that I could have rewritten this one is 1/2 to the x. This is called a exponential decay problem, right? Another way to write it is 2 to the negative x, right? 2 to the, so again, this is what I need your brain to see. So for those of you who speak 2 different languages, right? Like if I said hola in Spanish, right? My accent's a little off, forgive me, right? If I said hola, how would you say that in English? How would you say the same thing? So what I would write hola, hold on a second, let's write this down. So if I said hola, hola, my cursor is not working right now, right? Let's do that. So if I said hola, yeah, another way to say it is hi. I could have also said hello, junkie. And then there's just a bunch of different ways to say it. So notice, oh, it's not showing up yet, but notice those two words sound different. They look different. So here's hola, it's coming. But they actually mean kind of the same thing, right? Means the same thing. So these look different, they sound different, but their values are the same. That's what you need to keep seeing. So when you see these two things, you need to be like, oh, those are the same thing, right? $20 bill or 2 10s, right? Hola, hi, right? So same thing. Very good. All right, so now your turn. Can you write two different functions for this one? Can you write two different functions for this one? Now this one, this is exponential decay. What is this one going to be? Okay, go ahead and pause and I'm going to bring it back. Okay, so for this one, I know it's a little confusing, but if you reach back into what we did last time, we could figure out the base of this. And we know that this is going to be something to the x, right? Like, because this is the pattern that you guys are all used to seeing. And so what I'm going to do is I'm going to start plugging in numbers to see what I should get. So when I plug in 0, I get 1. That's true because anything to the 0 is 1 except for 0. When I plug in 1, I get 2. So if I plug in a 1 here, I should get out a 2. And when I plug in a 2, I should get a 4. So if Miss Johnson had her way and she built a little teeny weeny table, 0 would get 1, 1 would get 2, 2 would get 4. Does everybody see my growth happening? What is my growth factor? What is my growth factor? Yeah, it's just 2. So then that 2 goes right here. Now this is going to be weird. And this is where I'm going to have you pause again. This is in exponential land with a positive, like no negative exponents. Well, how do I say this? This is in one language. This is in Spanish. I need the English version of it. Does that make sense? Or this is in English. I need the Spanish version of this. So give me another version of this, just like we did here. Just like we did here. It's going to be a little weird. That's okay. Okay. So what I'm looking for is I'm looking for the English version. I'll just pretend. I'm looking for the English version of this. Okay. So since I already have the positive x version, that means I need to have the negative x version. Now, check it out. The 2 with the negative x, remember it means to divide. So we went 1/2, right? That's what happened to the base. We did 1/2, right? So if this is true, what should be my base here? So if you put -2, no, remember negative exponent, then we don't necessarily mean it to be negative. Now, someone said in the chat, to Miss Johnson, okay, is this true? I know you guys are just guessing, but logically speaking, what does the negative exponent mean? It means it wants you to divide, correct? Yeah. So our actual base, someone put it in the chat, very good. It's 1/2. Does that make sense? And it has to do with one of our friends earlier said that when you have a negative x, well, when you divide, because here it tells you to divide, and dividing by a fraction is really weird, right? So when we divide by a fraction, we're really multiplying. Where is it? Right here. We're really multiplying by the reciprocal. So this guy here would reciprocal himself to here. When you divide 1 by half. The question that, like, I want you to think about this because a lot of people are like, no, that doesn't make any sense. Okay, so if I have a brownie, okay, and I'm cutting it and I'm dividing it into half pieces. Listen to my question. I know we're back at food, y'all. This is my pink brownie. Isn't it so cute? It's really yummy. Okay, I'm dividing it into half pieces. How many half pieces are there? 2, right? Yeah, exactly. No, that's not what I'm asking. I'm asking this. If I cut it into half pieces, how many half pieces do I have? Yeah, I have 2 halves. That's why this is true. Because if I take 1 and divided it by half, it's 2. So these 2 things are the same, Miss Johnson? Yes. So Clarita, just to finish, says, wow, that's interesting. So how can I tell if an exponential function is always increasing or always decreasing before I graph it? Reminding you, increasing means you're on the roller coaster and it's going up, 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 up. Okay. Decreasing is when you're on the roller coaster from left to right and you're going down, 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 right? Okay. So does anyone have a really good way to tell? So how would you tell if it's increasing or decreasing? How could you tell if it's increasing or decreasing? Which one of these, number 9 or 10, is increasing? Which one of these, number 9 or number 10, is increasing? Yeah, number 10. Very good. So number 10 is increasing, 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 increasing. So looking at this versus this, looking at this versus this is how you could tell if it's increasing. What things should I look for? What things should I look for? Tell me about base. Tell me about the exponent. So for me, I'm looking at the exponent. Very good. I'm looking at the exponent, and that base, that's a 2. So if I wrote, this is what they're asking. If I gave you on a test and I said, okay, guys, I need you to tell me if this is increasing or decreasing. So I say 4 to the x. Okay, and I'm going to drag this. Should I drag this here to, oh, wait, here, wait, sorry, let's do this. So over here, I have increasing. And up here, we have decreasing. Okay. Is 4 to the x increasing or decreasing? Yeah, some people are noticing. Very good. Okay, 4 to the x. Okay, let me write another one. What about 3 to the negative x? 3 to the negative x, increasing or decreasing? Increasing or decreasing? Increasing or decreasing? Very good. It's decreasing, Miss Johnson. If you don't know, all your job right now is to be like, what made this one decreasing, Miss Johnson, and this one increasing? Okay, one more time. 1/2. Oh, I can't use 1/2 because 1/2 is the one that's right in front of you. Haha. 2/3 to the x. 2/3 to the x. Increasing, decreasing? Yeah, this one's actually decreasing. You'll see. You'll see, I promise. What about this one? Ooh, I want to try to trick you. 4/3 to the x. 4/3 to the x. Yeah. Why is this one increasing? What made this one increase and this one decrease? What made this one decrease and this one increase? Very good. I was trying to trick you guys and you guys didn't get it. Yes. Oh my gosh. Oh my gosh. Oh my gosh. Everyone, See, that's why I can't find my, oh, there it is. I got so excited. I couldn't find my snipping tool. I could not find my snipping tool. I'm so sorry. Okay, sorry. That's the weird accent whenever I'm in a hurry. I'm trying to hurry, guys. Yes, it has to do with the denominator because it's bigger. The numerator is bigger than the denominator. Very good. Okay, I'm going to try to, I know. Woo, woo. Okay, I'm going to try to trick you again. Here we go. Ready? Two-thirds to the negative x. 2/3 to the negative x. It's not showing up, y'all. 2/3 to the negative x. I'm trying to get you out of here. 2/3 to the negative x. 2/3 to the negative x. Increasing, decreasing. Oh no, we got decreasing. Actually, 2/3, according to what Alfred said, is it would be decreasing. But then to the negative x makes him switch sides to the increasing. I know, I so tricked you. Just kidding. I didn't want to trick you, but I really do want to test you. Okay, so with that being said, I want you to formulate some kind of like rules in your head. What would make it increasing? I'm pointing to the wrong one. What would make it increasing? What would make it decreasing? So here, Alfred came up with one of our rules because its numerator is bigger than the denominator. Okay, and that's true if our x is not negative, right? When we have that negative value, it's almost like this. It's like, look, it's smaller than 1, and you're heading off to decreasing, right? And they're like, but wait, it's negative exponent. And then when you drag it back over here, does that make sense? It's almost like he switched sides. Oh my gosh, I am so impressed by all of you. Really great job today. I can't explain how much that means, how much difference your learning will be when you answer questions.